What if gravity subtly weakened over decades? Imagine a world where everything feels just a little bit wrong. A world where your morning coffee mug seems to hang in the air for a fraction of a second longer, and where a basketball player can linger at the peak of their jump just long enough to make you question the laws of physics. What if the very force that anchors us to our planet began to slowly, imperceptibly diminish, decade after decade? This isn't the sudden, cataclysmic event of a Hollywood movie. This is a quiet, creeping change, a fundamental constant of our universe beginning a slow, inexorable decline. What would that world look like? In the first couple of decades, humanity might not even notice. The change would be so subtle, less than a fraction of a percent, that it would be lost in the noise of instrument errors and local gravitational anomalies. But then, patterns would emerge. Olympic records in high jump and long jump would not just be broken, but shattered, year after year. Athletes would be celebrated as a new generation of superhumans, unaware that the planet itself was giving them a gentle boost. People might report feeling lighter, more energetic. It would be a golden age of physical prowess, a time of subtle, unexplainable euphoria. The first real alarms would be sounded not on Earth, but in the silent vacuum of space. The orbits of our thousands of satellites are a delicate ballet, a perfect balance between their immense forward velocity and Earth's gravitational pull. As that pull weakened, satellites would begin to drift. Their orbits would slowly expand, spiraling gently outwards. GPS systems would require constant, increasingly aggressive corrections. The International Space Station would need more frequent engine burns to avoid drifting into a higher, unusable orbit. For astronomers and engineers, the data would be undeniable. The Earth was losing its grip. Down on the surface, the natural world would be the next to respond. With less gravitational force pulling them down, plants would engage in a silent, slow-motion arms race towards the sky. Trees would grow to titanic, unprecedented heights, but their wood would be weaker, less dense, as it wouldn't need to support the same immense weight. Birds and flying insects would find lifting their own bodies almost effortless, allowing them to achieve greater heights. Yet this advantage would be a precarious one, as the slowly thinning air would offer less purchase for their wings with each passing generation, demanding new evolutionary paths. For humanity, the biological implications would be profound and generational. Over a century or two, with less constant stress on our skeletal systems, humans would begin to grow taller. But this newfound height would come at a cost. Our bones, no longer needing the same density to support our weight against gravity, would become more brittle. Our cardiovascular systems, designed to pump blood up to a brain against a powerful force, would become less robust. We would become a species of graceful, towering, yet fragile beings, perfectly adapted to a world that was slipping away. The most terrifying consequence, however, would not be felt in our bones, but in every breath we take. Earth's gravity is what holds our precious atmosphere, our blanket of life-giving gas, clinging to the planet. As gravity weakened, the atmosphere would begin to expand upwards, becoming less dense. Over centuries, the air at sea level would thin, resembling that of high-altitude mountains. The sky would shift from a familiar azure to a darker, deeper blue, and our protective shield from solar radiation would diminish. Earth would slowly begin to suffocate. Our oceans, too, would be in turmoil. Gravity is what pulls the vast bodies of water into a relatively uniform sphere. With a weaker pull, the centrifugal force of the Earth's rotation would have a greater effect. Water would begin to bulge more dramatically at the equator. The tides, now dominated by the moon's proportionally greater influence, would become monstrous and unpredictable. Coastal cities would be threatened not by a simple rise in sea level, but by a catastrophic redistribution of the world's oceans, redrawing coastlines with every chaotic surge. Faced with such a fundamental crisis, human ingenuity would be pushed to its absolute limit. Architecture would be reborn. Buildings would no longer be about fighting gravity, but about achieving stability in a lighter world. We would see impossibly tall, spindly structures, perhaps even tethered to the ground, to prevent them from toppling in extreme weather. To combat the thinning atmosphere, Vast, sealed domes might be constructed over cities, pressurized oases where life could continue as it once was, a stark reminder of the world we had lost. Centuries would pass. A human from our time transported to this future Earth would barely recognize it. The descendants of humanity would be giants, living within enclosed biomes, looking out at a landscape of strangely overgrown, fragile forests. The moon would utterly dominate the night sky, its gravitational pull a source of both awe and terror. The simple act of dropping an apple would become a strange spectacle of slow motion. We would be aliens on our own homeworld, a species forever changed by the slow decay of a single, universal law. Ironically, the very force that threatened our existence on Earth would offer us our only escape. With weaker gravity, launching rockets into space would become exponentially easier and cheaper. The energy required to break free from Earth's grasp would be a fraction of what it once was. A grand exodus, once the dream of science fiction, would become a practical necessity. Our fading world would, in its final act of transformation, push us out into the cosmos to find a new home with a more reliable anchor. The slow death of gravity reveals a profound truth. We are creatures shaped entirely by a force we never see. It is in our bones, in the curve of a thrown ball, in the pressure of the air we breathe, and in the shape of the world itself. It is the silent, omnipresent partner to every moment of our existence, a constant so reliable that we forget it is there at all. So the next time you pick up a book or feel the reassuring weight of your own body in a chair, take a moment. Appreciate that invisible, universal embrace. Because in a world where that embrace began to loosen, we would learn that the heaviest thing we can ever carry is the loss of a constant we once took for granted.